Welcome to Saxon Math Course 3, Investigation 10. Now, Investigation 10 is about compound interest. Compound interest is a type of interest which will compound upon itself. Now, remember that we've talked about compound shapes before, where with a compound shape, it's two shapes put together. A compound interest is when you put the interest from a principal together with the principal and then find the interest again. Now, I've used a couple of vocab words, and let's talk about what they mean. A principal, in addition to being the person who runs a school, when we're talking about interest, is the original amount of money that was deposited. It's what you've invested. It's what you start off with. If we were representing this as a sequence, it would be our A sub 1. Now, our principal, what we start off with, is then grown based off of an interest. Interest is the amount, if you have money in a bank, the bank pays you. Or if you have some other investment, it's what you make off of the principal. Now, interest comes in two forms: simple interest and compound interest. Simple interest is only ever paid on the principal, not on previous interest payments. You only get the interest on what you started off with. Compound interest payments pay interest both on the principal that you started off with and on any previous interest payments. Let's look at what those look like. Now, if I had a simple 5% interest on a $100 principal, then after 1 year, I would get to add 5% of 100. Well, 5% of 100 is 5, and 100 plus 5 is 105. In the second year, I would add 5% of 100 again, because simple interest only pays interest on the principal. 5% of 100 is 5, so we add 5 to get 110. 5% of 100 in year 3 will be 5 still, which will give us 115, and in year 4 we'll have 120, because we're adding 5% of 100 again. On the other hand, compound interest pays interest on the principal and on any previous payment we've had. That means it acts almost like a recursive statement. So at our first year, year 1, we will still have 5% of 100, giving us 105. But in year 2, we'll have 5% of year 1, or 5% of 105. Now, 5% of 105 is 5.25. So we're going to get 110.25. In year 3, we'd have 5% of 110.25. That would give us 115.76. Then in year 4, it'd be 121.55. So you can see that even across 4 interest payments, compound interest is already giving us more than simple interest would have. This effect is increased even further if we go further into the future. These payments start increasing exponentially in the compound, but only linearly in the simple. We're only having a direct variation here. If we had a graph of this, it would be a straight line. This graph, the rate at which it changes gets bigger every time, which means you would have a curved graph that would eventually become almost vertical, getting a lot of interest many, many years in the future. If you look in your textbook, for which you're using to do your homework, you can look at the table on page 671. It shows this same compound interest expanded out over 3, 10, 20, 30, 40, and 50 years. And at 50 years, the simple interest is $350, and the compound interest is $1,146.74. So you can see, after an extreme amount of time, compound interest becomes much, much greater than simple interest. So let's look at our first example. Example 1 says, make a table that shows a value of an investment growing by of $1,000, growing by 10% for 1, 2, 3, and 4 and 5 years. So, how would we find this? Well, we can write a recursive formula. The recursive formula we're going to write, well, if we're increasing by 10%, 10% is 100% plus 10%. As a decimal, that would be 1.1. So we could use the recursive formula that a sub 1, what we start off with, is 1,000. And a sub n is 1.1, our growth amount, times a sub n minus 1, the number before it. Now, since we say that our principal is a sub 1, that means that year 1 is a sub 2, because it would be the second one. Year 2 is a sub 3. Year 3 is a sub 4. Year 4 is a sub 5. And year 5 is a sub 6. So, let's start off with a sub 1. Now, a sub 1 is, a sub 2. Because a sub 1 is just 1,000. Because it's given to us. A sub 2 would be 1.1 times a sub 1, which is 1.1 times 1,000. That will give us 1,100. A sub 3 will be 1,100 times 1.1. Now, if you need to use a calculator for this, you can. When we're doing interest payments, I'll allow you to use a calculator. 1.1 times 1,100 is 1,210. We're going to then take a sub 3 and put it into our formula for a sub 4. 1,210 times 1.1 is 1,331. We then take a sub 4 and put it into our formula for a sub 5. Now, 1.1 times 1,331 is 1,464.10. Now, we'll take that and put it into our formula for a sub 6. And 1.1 times 1,464.10 is 1,610.51. So now we have all of our values. So we just need to put it into our table. So a sub 2 was 1,100. A sub 3 was 1,210. A sub 4 was 1,331. A sub 5 was 1,464.10. And a sub 6 was 1,610.51. And this is all dollars. Now, this was just showing us how we would find compound interest using a recursive formula. We take our growth rate and we multiply it by the previous term. That's all we have to do. Now, since we know that we're just multiplying every time, you can see that this is a trend of repeated multiplication. So we could say that our specific formula, a sub n, is equal to 1,000 times 1.1 to the power of n minus 1. Now, this may look tricky because we haven't done any specific formulas in this form, but this just means that whatever our number is, whatever our number of years is, we're going to take that and we're going to multiply by 1.1 that many times. It's the same repeated multiplication we did in the problem before. Now, this is handy to have because this can allow you to use a calculator to work through the problem. Now, the activity on page 672, you can use a calculator on. You're supposed to use a calculator on it. If you don't own a calculator, simply go to desmos.com/calculator. I'll put a link to this on the homework assignment. Now, moving through to rule of 72. If an account has compound interest, we can find how long it will take to double using this formula. 72 divided by the growth rate, or interest, is equal to the doubling time. Example 2 says, apply the rule of 72 to estimate how quickly an investment will double with 6% interest. Well, our growth rate is 6%. Now, we would divide 72 by 6. Now, 72 divided by 6 is 12. That means the investment will double every 12 years. So we can use this information to make predictions into the future. So we can talk about 12 years. After 12 years, it'll be 24 and 36, or even 48. These are multiples of 12. 1 times 12, 2 times 12, 3 times 12, 4 times 12. Because after 12 years, it will double, so it'll be 2,000. After 24 years, it will have doubled again, meaning it's 4,000. 36 years, it will have doubled from the previous one, 8,000, and 48 becomes 16,000. Now, if you're asked to find a value such as this, you first want to find the doubling time, and after finding the doubling time, make a table. Find out how many times it doubles, fill it in, and find your answer. All right, that was our lesson for today. It was a pretty quick one because it's the investigation. You have a little bit less homework problems today. You only have 11 of them. So you have the investigations activity 1 through 5 and 6 through 11. I expect you to turn all of them in. I'm going to have this video be in the assignment, so you'll have a space to turn it in the upper right hand corner. Please make sure you complete all of your homework, stay safe, stay inside, and wash your hands.